Okay, well, first of all, I'd like to welcome everyone to our session, Introduction to R with Power BI. And so this session is for people who haven't really used R very much in the past, or maybe you've used R but haven't integrated it with Power BI. And so what we're going to look at in this particular session, let me go ahead and get to our agenda slide, is we're going to spend just about 5 minutes just with an overview of the R analytics platform, talk about what it is, and then about another 5 minutes talking about how to set up your environment with Microsoft OpenR and RStudio. And most of the time we're going to spend looking at code. So hopefully this is a webinar that you'll like because you like looking at code and getting started with things. And I'm going to spend about half the time with RStudio and writing some basic R code, getting you up and running, showing how to write the code, how to execute it, how to debug your code. And then we're going to turn over to Power BI Desktop and see what we can do inside there. Now, just a quick plug, one of the things that my company does is technical training. So we have a Power BI boot camp, and we're teaching it in Tampa, or you can attend remotely. One the week after Thanksgiving, November 29th, and one in January. Okay, let's go ahead and also note that the slides and sample code for this webinar are available to you. And if I go ahead and click on this link right here, what I should be able to do is show you that there is a GitHub repository. And for instance, here's some of the code that I'm going to be showing. For instance, if I drill inside here. So if you want to be able to download this code, and there are some R scripts, there is both a PDF and an SPX file of the slides, and then there are 2 different Power BI desktop projects that I'm going to show. So please go ahead and navigate to that repository and leverage what I've done here if you really want to dig down a little bit further. Okay, great. Well, let's go ahead and jump in. Well, first of all, what is R? So R is a data analytics platform, and it's used very widely by people who get involved with statistics and data analysis. And then also, in addition to being able to crunch numbers with some type of advanced statistical type functions, it also gives us very good data visualization capabilities. Now, another nice thing about R is that it is quite a few things, but all those things are free and they're all cross-platform, which means that if you're working on Windows, that's great. If you're working on the Mac or Linux, there is a version of R that you can install, and there are very popular tools that you can install and work on any type of platform. So it's really open source software. Now, another thing to think about it is some people think about R as a programming language, where I think you should really think of as R as something that has a programming language. So you can think of R at a high level as a programming language plus a runtime environment. So you have to install a bunch of DLLs if you're on Windows, and other things if you're on other platforms. And then there's a set of different libraries. Now, our code is distributed and versioned using these units of code that are called packages. So there are going to be some core packages that are available automatically when you install R, but then there's also tons of other packages that the community has created. So one of the things that's made R so popular is that there are all these different authors out there, and they're all contributing incredibly valuable code to the common good, code that once again is open source cross-platform and you can use for free. Now, why do you need R? So maybe you need to analyze data, you need to generate statistics. If you're at this session and you're thinking of integrating it with Power BI Desktop, a very obvious place to start, and what I think of as one of the low-hanging fruits of R, is being able to create very rich graphs and charts and basically use them in the Power BI environment. Okay, now with R, you can get very, very deep. You can basically create statistical models for predictive analysis, and that's one of the big reasons why R is becoming so popular. In the BI world, a couple years back, all we really thought about is creating projects to tell us what happened in sales over the last year. But now, having BI systems that tell us what's happening right now, doing things like detecting fraud, or what's going to happen in the future with predictive modeling, are getting to be more and more important and more pervasive. And R is one of the leading platforms that we use for predictive analysis. Now, let's talk a little bit about R packages. So R packages are units of code, but it's more than code. It's code and data and functions. And the idea is that when you install R, you're going to get all the out-of-the-box packages installed along with the default installation, but there are other packages that you can find, locate, and you can download, install, and begin using. So while R is installed with a default set of packages, other packages can be downloaded and installed, and quite often that requires your attention. When you start leveraging some of the packages, you go to a new machine where R is just installed, you're not sure if the packages are going to be there, so quite often we have to write some extra code to make sure that the package gets downloaded and installed before we try to use the functionality inside of it. Now, what are some examples of domain-specific packages? Well, sometimes they just do grunt work. You know, for instance, if you need to download data for statistics that someone has published in zip archives, you know, someone has done the grunt work to write a R package that is able to download a zip file, extract the files out of it, start pulling out and being able to read the data inside there. Now, there's also packages to create fancy charts and graphs. So there's 3 popular graphics packages that we're going to look at today. But then again, you can also create packages to have some advanced statistical analysis of financial portfolios. There are packages that you can download that are going to be able to predict component failure times. And you've probably seen commercials by things like IBM talking about data analytics, and I have some geneticist on there who talks about how they're predicting gene sequences. You know, most of that work today is also being done in R, and there are R packages that have that logic in there to be able to predict genomic gene sequences. Okay, don't ask me about that. I don't know much. Now, the next thing we have to look at is where do you find these packages? So the R community has created this extensive network called CRAN, the Comprehensive R Archive Network. You can download packages from this particular location, and what you'll see if you go to this URL is, first of all, you can download and install the binaries for R so you can start doing work, and then there are also these servers called mirrors. And so what you're going to see is that there are tons of servers that are located near you where you can basically download your packages from. Okay, so that's what we call CRAN. Now, Microsoft has stepped in and they've created their own distribution of R, which is called Microsoft R Open. And really, it's an alternative to the installation of R that you can get from CRAN. Now, why did Microsoft do this? Well, one of the problems is the code that gets installed when you install the R platform from CRAN is basically written for people who are working on a single desktop, and as they try to generate, you know, very large models and do a lot of processing, it can take some time. But Microsoft's plans are to use R in many places, including server-side scenarios where there's a lot of concurrency. So one issue that Microsoft had was that the regular R platform just did not have concurrent code to deal with multi-current, multi-threaded environments. So basically, they have an implementation that has, you know, tightened up that. Now, they also have their own math library, which basically can give better performance. Once again, typically in server-side scenarios, but even in client-side scenarios, if you're just basically running the R code on your desktop and you're crunching through 100 million rows and you're doing some arithmetic operations, you know, you can get a performance improvement because of what they have inside there. Now, another thing that Microsoft saw is that you have all these different packages. And so let's say I install R, and so I have a set of the default packages, and then I pull in another package from author A, another package from author B, another package from author C. Quite often things get out of whack because one author hasn't kept up with the current libraries of the base installation. So Microsoft also has done work where they have kind of a snapshot of all the libraries at one point in time. And so by using Microsoft R Open, you can get rid of some of the versioning issues that can surface when you're using CRAN. Now, how much money is Microsoft making off this? None. Just like the regular R platform that you can install from CRAN, this is free. It's cross-platform, so you can install it on a Mac or Linux box as well as on Windows, and it's open source software. So Microsoft plans to make money on the products that they build on top of this. But they see a huge future with R, so by creating their own implementation, they're able to control the performance and the multi-threading support and a little bit of better stability through package versioning. Okay, now this is available for download. Now, before we get to the next section, what are the stages of R awareness? So if you're just starting with R, as I suspect many of you are, well, stage one is standing up, installing R, whether it's from CRAN or whether it's the Microsoft R Open, and then basically starting to write code, playing with data. Okay, now the next stage, and this is something you can get to within a week or two, writing and testing R code and creating graphs, whether it's in RStudio or in Power BI Desktop. Now, it will take a greater investment to start getting into things where you're starting to load packages and load data sets and to generate advanced statistical analysis. But once again, your background with statistical analysis is going to be important. But this is something that people can get up to speed on over a matter of months and definitely within a year. Now, what takes a lot longer is to get really good at creating domain-specific predictive models. So give yourself a couple years if you're really going to get to that level of working with R. Okay, and then sprinting. So the idea that you've got this amazing thought process to predict, analyze gene sequences. So you're able to figure out, how to build a predictive model, build it inside R, and then be able to package it and push it out so the rest of the world can use it. So that would be the different stages. So I'm thinking people attending this, stage 1 and 2, completely accessible to you. Stage 3, maybe you should see as kind of a longer term, several month investment on your part. Okay, now let's go through installation. So the first thing that you want to do is you want to go to this URL, and there is a download, and you will install the Microsoft R Open platform. Earlier this week, it was at version 3.3.1. And then also another thing they ask you to install as part of the installation is the math kernel library, which can give a nice performance boost when you're crunching really large sets of data. Okay, now once you've installed that, you're going to have a command line. Now, for instance, let's say that I've just installed R Open. And so what I have is a command line. So here I am at this command line. Let's go ahead and do a Control L. Hold down the Control key and hit L to clear the screen. So, let's say that I have a variable, and that variable is X. So I could say X equals 10. That works just fine. But what you'll find is that in R, generally, we don't assign variable or object values with the equal sign. Instead, we use the assignment operator, which is less than and then hyphen. And we'll go ahead and we'll add that inside there. And so, you might ask, why do they do that? And it turns out that you can actually use the equal sign. It works just fine. The problem is, let's say that we want to see if two things are equal. So if I say X equals Y, what's going to happen there is you use the double equal sign. Now, if I look at Z right here, you can see that Z is true. But I think the reason that everyone tells you to use the assignment operator is that if I was writing this line of code and I made that mistake and I'm doing assignment, okay. Now, the real reason that you want to use the assignment operator, which is basically this right here, is that other R programmers will think you're a newbie if they see you use the equal sign. Okay, that's just a little getting started. We're not going to write much code inside of this console, but that's what you get when you install the Microsoft Open R version or you install R from CRAN. So what we really need is a better tool. And so that tool, which comes for free, is RStudio. If you use Visual Studio, there are some new tools that integrate into Visual Studio for writing R code. But even today, I would say that most people using R, are going to prefer RStudio just because it's evolved. It has a very friendly coding interface, as you're going to see over the next couple demos. Now, you're going to find the version that you want. For instance, I'm running Windows, so I'm going to install the Windows version inside there. And then we have this really nice IDE that we're going to start working with. Okay, so once you've installed RStudio, let's go ahead and fire this thing up. So once we have RStudio, you have a console here. Now I'm going to go ahead and hold down Control and hit L. And when I hold down Control and hit L, it clears the console. And now I can say, new file, give me an R script. And so if I want, I can go ahead and save this, but now I have this R script file. And the idea here is that let's do a hello world. And once I have hello world inside here, if I want to execute a line of code, I simply put the cursor where that line of code is, and I'm going to hold down the control key and hit enter. And what you're going to see is that is going to run that line of code. Let's go ahead and write another line of code. And I'll say print message, and notice that they give me IntelliSense inside here. And so if I go ahead and run that, things work. Now let's look over here where it says environment. Now there is something that says clear objects from this workspace. I'm going to go ahead and clear those out. And what you're going to see is that there's this notion of your current session, which in R we refer to as a workspace. So when you create a variable, which in R we call an object, all of a sudden you'll be able to see that over here in the values. And also I can come down here and I can go ahead. Now let's say that I want to get rid of all the objects in my session. So in R we have a lot of strange functions. There's an RM function for remove. So if I say list equals objects, what that gives me the ability to do is to basically remove all the different objects inside there. And yes, there is an S at the end. And so now I remove the objects inside there. Okay. If you want to move back and forth between the console and the source file, Control 1 and Control 2 will basically move back and forth. Control L will always clear the window inside here. And then the last thing that I want to show here is that when you're working with a script, while it's possible for you to hold down the control key and do enter, enter, enter to run all the stuff, it's also possible for you to come up here and to basically go to source. So source means run the script, which is the source. And so when we call sourcing, we're basically just saying run the script without me having to execute each line by itself inside there. Okay, so that was just a quick introduction to working with RStudio and its IDE. Now, the next thing we're going to look at is, okay, next thing we're going to look at here is writing some code. Let's just kind of go through some samples and see how we start writing code. So when you start working with R, you're going to basically have a folder structure, and every folder can be seen as its own project or its own working directory. And so data and scripts can be added inside there. You can call getWD to get the working directory. And then there's also library paths. So when you install packages, they get downloaded inside there. Now, each R project defines a workspace, which is basically an environment for loading objects inside. And the workspace also defines what packages are loaded in. And you can write code to load in a package, or you can configure RStudio to automatically load the package for you, so you don't have to handle that inside code. And if you want, you can take your entire environment and you can basically save that so that all the data, all the objects that you've loaded in are saved, which could include really large data sets that you've imported once and don't want to keep importing. Okay, now I'm going to go through a whole bunch of different scripts. And the idea was if I go through some scripts to show you the basic syntax, and then after the webinar, you can take the exact same scripts and run them in RStudio, it's going to be a good learning experience. Okay, now along the way, when you create variables or objects, realize that your names can contain letters or numbers. They cannot start with a number, but they can contain letters, numbers, underscores, and dots. So in some programming languages, you might have something such as class 1 dot method 1, and so the dot kind of symbolizes a path from a parent to a child. In R, it doesn't do anything like that. So dots just give us a friendly way to name our variables so that it's easier for us to organize things inside there. But the dot doesn't really have any type of meaning as far as a sub-object or a child inside there. Now, there are a couple essential data structures that you have to know about when you work with R. And so we're going to start with them in RStudio, and they're going to be very important that you know all these before you start trying to take your R efforts into Power BI. So first of all, there's a vector, which is just an array. It's a one-dimensional single mode array. And when you hear the term single mode, it just means every element in the array has to be of the same type. They can all be numbers, they can all be Booleans, they can all be strings. You have the matrix, which is a two-dimensional single mode array. So it's kind of like a table, but everything in the table has to be values of the same type. So it's not really a flexible table. You have the array where the vector and the matrix are one and two dimensional. The array is just any number of dimensions that you want. So you can create a three-dimensional array. Now the next thing is a list. A list is where we start having multi-mode objects. And a list is going to be very simple in the fact that it just gives you the ability to add elements or items into a list, and every item can be of a different data type. And then there's going to be the magic data structure, which is called a data frame. And the data frame is basically going to be a list, but it's going to be a very structured list that has a set of vectors that all have the same length, and we'll see that in just a second. And the last thing that you have to know is something which is called a factor. So we want to step through code examples to basically show you, what each of those are. Okay, so let's go ahead and run through some code examples inside there. So let's go ahead and we're going to move back to RStudio. And inside of RStudio, I'm going to go look at the code that I have provided for you inside of our GitHub repository. So let's start with the getting started. Okay, I always like to do a Control-L, clear out the thing down inside here. Okay, so what we've already seen is things like assignment. I take something and I want to assign it, then I can print that. Now, let's say we want to create a vector. So one simple way to create a vector is by using the C function. When you see the C function, that stands for combine. So what happens when I do a Control-Enter and I create this particular vector inside here? You can see over here that the vector is numeric. It's got 4 elements that are 2, 4, 6, and 8. Great. Let's look at a couple other ways to create vectors. So vector 2, I'll just create as 1 through 10. So you can see there's some friendly syntax for defining sequences. Well, maybe I want lowercase letters. So there's also a letters data element that you can use. And so you can see I've gotten the first couple elements inside here. Okay, how about uppercase letters? There's also something I can use to create that. Now look at this one right here. I have 2 raised to the power of, and now I have a vector of 1 through 8. So as I go ahead and run that right here, you can see that it simply gives me a vector that contains, one element, for each in the sequence. Okay. Let's say I want to have election years. So now I'm going to use the sequence function inside here. Now, when we call functions in R, sometimes you just include a single parameter and you don't have to give it a name, but there are many functions in R that have name parameters. So when I call sequence, what's the year I want to start, what's the year I want to end, and what's the increment in the particular year? It's going to be by 4. And so we go ahead and now we have election years. Once again, the dot has no meaning. I can just basically create an object that has election.years as its name, because for me, it's easier to have the dot in there for readability because I want to keep all my objects at lowercase. Okay, now as a programmer, sometimes we like to do for loops. So here's just kind of a simple example of going through a for loop. And you can see down here in the output, We've written all those. And let's say that now I've used all that data and I want to get rid of the objects inside there. Let me go down here for 1 second. Note that while this is running, I can always go to the console, and let's say I go to objects, and inside of objects we run that. We can see everything that's inside there, but once we go ahead and execute that one line, you can see that all the objects or all my variables have been purged from the current workspace. Okay, that's good stuff. Let's go ahead and look at some more code. Let's talk a little bit more about vectors. Okay, I always think of airplane and what's your vector, Victor? But in this case right here, I want to show you just the nature of vectors and performing mathematical operations on vectors. Everyone always has this statement that R is a vector-based language. And the idea is that everything you create, x equals 10. Oh, people are going to think I'm a Wally. I better go ahead and use this operator instead. Let's go ahead and look at the value of x, and you can see they took that and they put it into a one-element array or a vector. Okay, great. So let's go ahead, and the first thing we're going to do is that we're going to create a vector and print it out. Okay, that's great. Now, another thing about vectors is that they have all these different elements, 34, 56, 39. I can give every element in a vector a name. So if I call names my vector, and then I want to apply something like month names inside there, let's go ahead and execute that right here. And now what you can see is that instead of just having these subsets inside there, I have named every element inside. So when you create two-dimensional arrays, which are matrices, you can name the rows and columns. And when you create three-dimensional, you have basically three dimensions in which you can name the things that are inside there. Okay, now watch this. Next thing we want to look at, let me go ahead and remove x from inside here. So once I remove x and clear here, let's take a look at this vector. 34, 56, 39, what a winning hand. What we're going to do is we're going to take the vector and multiply by 2. And watch the effect. It basically goes to every element inside that vector and multiplies those values by 2. So one of the really neat things about R is that in many other languages, you would have to write a for each loop to go through and basically modify each of those elements. But because of the vector arithmetic, it just becomes so much easier to write that code. Okay, now you have a vector, and remember that vectors are 1-based, not 0-based. So this first element, 68, is 1, 2, 3, 4, 5, and 6. Let's say I just want a subset of what's inside there. I go ahead and ask for 1, 3, and 5, and that's what I get, 1, 3, and 5. Okay, now also, watch this trick. Instead of passing C, 1, 3, and 5, I'm going to put a minus sign in front of C. And so what that says is, this is not what I want included, this is what I want excluded. So if you have 100 elements and you just want to take out 3, it's a lot easier to specify the ones you want to remove as opposed to the ones that you want to include inside there. Okay, now also here's just some regular functions that are built in. If I want to figure out, what is the length of a vector, what is the sum of the numbers inside of that vector, maybe I want to say what's the difference between the first and second, and the second and third, and the third and fourth. Okay, and then maybe I want to go ahead and sort the vector inside there with values ascending or descending inside there. Now, let's say that with our particular vector, I want to figure out which of these numbers are greater than 100. So there's a really neat thing, which is which. And I can say which vector greater than 100. And when I do that, it gives me back the index values. Okay, but now if I say my vector, and then I specify those subsetted values inside, I don't get the index values, I get the actual values inside there. Okay, now another thing to really think about, a vector is a single mode array, and what that means is it always has to be the same type. Notice that right now it says named number, and you have these 3 or you have 6 values inside. Now, let's say that I want to go to one of those elements and I want to change it to a value, but that value is not numeric. It's going to be a string. Go ahead and watch what happens. It can't just change one of the values. R automatically takes the entire vector, which has to be single mode, and converts it over to a character-based. Okay, now what's going to happen when I try to perform more arithmetic, on that? I go ahead and try to run that operation. You can't do that because you can't multiply string values together. So just understanding the vector-based nature of the programming language and of the platform, gets to be important. Hopefully this quick demo kind of showed you some of the important aspects to surface inside there. Okay, let's keep going through here. Let's go ahead and close these first two. I've got a couple more code demos that I want to get through just to cover some important concepts. So let's go to data types. Now with data types, you've seen that you can create a vector. Okay, great. Well, you can also create a matrix. So a matrix is just two-dimensional instead of one-dimensional. So if I say something like, give me 12 elements and spread them out over 3 columns and 4 rows, what we can see here is that enter, control, enter, and I see the matrix down inside here. Now, once again, if I felt like giving names so that you don't have to look at these strange index numbers, that would be possible for you to do. Now, you've seen how to create a vector. You've seen how to create a matrix. If you want arrays that are 3 or more dimensions, you just use the array. And so here I'm going to say basically give me 12 elements, but now how many dimensions? I have 3. The first is 2 dimensions, the second is 2 dimensions, the third is 3 dimensions inside here. So now when we create this array and we now print it out, what you can see here is that, well, there's the first dimension. So when you kind of create 3 dimensions and you have a cube, you have rows and columns, and the third dimension we generally call slices. So here's the first slice and the second slice and the third slice inside there. Okay. Now, if you're really good at visualizing things, you could create arrays that have 4, 5, 6, 7, 8, 9, 10 dimensions. Okay. My Uncle Wally can basically abstract in his mind, only up to 8 dimensions, so we always give him a hard time at Christmas. Okay. Now, next thing we want to do is create a list. So let's go ahead and I'll clean up the console. Note that if you don't want to write code to remove variables from your session, there's also this little paintbrush up here, and the idea is you click on it, and it's the same thing of removing all the objects. Okay, now let's go ahead and create a list. So when you create a list, you're able to add any set of values, and they can be name values. So in our case right here, we'll go ahead, we'll run this code, we'll go ahead and print out this particular list right here. Now, note that once you have the list, sometimes up here, you can see that next to the list, they have this little forward arrow. I go ahead and click on that. So RStudio kind of gives you a quick way to see what's inside of that list. Now, another thing to see is once you have a list, and some other data structures support the same syntax, you have name properties, and the $ becomes important. So when you say list, $, and then list property or list item name, you can basically get that value back inside there. So I go ahead and I get that value. Now you've seen the list. So now here's the magic moment where we introduce what's called the data frame. Now lists don't have that much structure. You can put whatever you want inside of a list. However, a data frame, you can think of it as a list, but the list is restricted on what you can include. So you can include vectors. So remember, every vector inside there is a single mode array. So what happens here is you basically create a data frame from a set of vectors, but every vector is required to have the exact same length. Okay, so let's go up here, and we're going to create a vector for year. We're going to create one for region. We're going to create one for sales figures, and we're going to use those 3 vectors to basically create the data frame. Now, RStudio is really neat in the fact that once you have a data frame that's created, you can simply click on it, and inside of the window, it will actually open the data frame and allow you to visualize what that looks like. Okay. Now, the last thing I want to point out is something which is called a factor. And the idea of a factor is that you have a list of values, typically string values. So let's say in the customers table, you have male and female, and you have 1 million customers, so you have 1 million values that are male or female, but yet there's only 2 values. So when you create a factor, what you're really creating is something that's kind of like an enumeration if you use programming languages. The idea is it's an integer-backed value. So the first value is going to have 1, the second value is going to have 2. So factors give us a lot of performance advantages. And what you'll see is when you start working with data frames, some of the columns are going to be required to be factors and not just regular vectors with character values inside there. Okay, now let's keep moving, and let's go ahead and move to something with packages. Real quick for packages. Let's say that there are some packages and you know that they're not installed by default in either our Open for Microsoft or in the regular CRAN. So you can either click on packages in RStudio and you can choose install and you can load things in, or you can write code that basically looks at, is this installed package already there? If it's not, go ahead and install it. So you can write code that's safe, and then what's going to happen is once you know the package is installed, you call library to actually load the package in and make it available. Now note that when I called this, I got a couple warning messages. And so sometimes you load in packages and they basically mask other functions. So the idea is that there's a core function named filter inside of R, but when you load this package, it replaces the out-of-the-box filter function with its own filter function inside there. So sometimes you'll get some warning messages from those inside. If you ever want to unload a package to basically reduce the memory inside your session, there's some code that shows you how to do that as well. Now, let's keep moving. And next thing we're going to look at is importing data. So there are a host of different functions in R. So what I'm going to do is I'm going to do something very simple here. There is, in the GitHub repository, this file, which is sales by customer CSV, and this is just available via anonymous access. So over here, we're going to say read CSV, and we're going to call that inside there. Now, let me go ahead and clear the objects that we have here. Let's go ahead and run this function right here. And as I run this function right here, it's created a new data set from that CSV file. I can take a look at it, open it up. Now, first thing I see is the customer, the column names, aren't really what I want them to be. They're a little bit messy inside there. So maybe we'll go ahead and rename those particular columns inside there. So by having names, customers, now we can go through here and you can see that I've renamed those columns inside. What are some of the other things I could do? So maybe I want to sort. So here's a way that I can sort by the customer age inside here. Once again, I open it up and you can see that we have all the old folks up top, younger folks down below. Okay. Now maybe I want to find a subset of the data inside there. So here's a subset function. Take customers and only give me those that are in the state of Florida. And then I don't need every single column. Just give me the customer and the age column inside there. And so we'll go ahead and we'll run this code here. And so now I've created a second data set inside there. Great. And then let's have our first example with some charting. So here I'm going to create a histogram, and there's just basically some code. And what's really kind of neat about working with RStudio is there's this idea of the default output device. And when you create charts and you don't specify where to put them, they just go to the default output. Okay, just a couple more scripts here I want to run before we get on to the next section. Let's talk about creating charts. So what I'm going to do in this is, first of all, let's go ahead and create some sample data. So here's just a way to create a set of 1,000 points in a normal distribution. Okay, now let's say that I want to create chart type 1, a histogram. We'll go ahead and create that inside there. And you can see over here, here's my histogram of the data. Okay, well, let's create a second one. Let's create a box plot. The idea of the box plot is it shows you the 4 quartiles of the bottom 25, the 25 through 50, the 50 through 75, and the 75 through 100%, and how they lie in something. Okay, there's also something which is called a QQ plot, very popular among statisticians. And then there's also plot inside there to do a regular scatter plot. Now, let's say that there's those 4 charts, yet I want to put them into a single graphic. So what you can do is you can use the par function, and you can say, I want to create a chart frame which is 2 by 2. And let me put the histogram in the first one. Let's go ahead and put the bar chart in the second one inside there. Let me go ahead and see if that, okay, it's not working for some reason. Let me try that one more time, see if I can get that working. Okay, so down here, okay, somehow things stop working inside here. Why that is, I'm not exactly sure. But the idea is that you can create things that put more charts, multiple charts onto a single graphic output. And then there's this technique down here. If I say png mychart.gmp, I can now say I don't want to write to the default output. I want to write to a specific file. So here, if I go up to Documents and I find mychart.png, you can basically see the output file. Now, one thing to note is when we get over to Power BI Desktop, you have to use the default output. You can't do any tricks where you've kind of switched the output device to a PDF file that you're generated inside there. Okay. Now, one last thing I want to do here is talk about writing functions. Now, first thing is I didn't write this function. There's Naomi B. Robbins, who is one of the great contributors to the R community, and she wrote this particular function right here. But what I want to show is that in R, we can create functions. And the idea is you have all this difficult code, and instead of having to rewrite this, if you put it into a package and you have that particular function, now we can go ahead and use that inside there. So here, we've created a function, and you can see this function has been loaded in. So now, with her function, I'm going to take my data, call her function inside here, and now, once again, for some reason, this is not working. Let me try something real quick. If I close RStudio, open it back up again, this is just a really pretty chart, which is why I wanted to close and start one more time to see if I can get this working. Okay, so once this function has been loaded in, and now we go down here and you can kind of see the output as well. Okay, for some reason the other thing wasn't working, but now I think we're time-wise we should go ahead and move on. Okay, so one of the things that you've seen there is basically writing and testing code in RStudio and starting to get up on the syntax and the basic coding fundamentals that you need when you start using R. Okay, so now what we're going to look at is how do we take our skills of writing R code and being able to integrate that with Power BI Desktop. Now, there's some really nice improvements that have been coming each month over the last 5 or 6 months. So as of September, that's the release of Power BI Desktop I'm using, there are now 3 different places that you can use R code in Power BI Desktop. The first one is as a data source. So if you've written code to import data with R, you can basically just use that to pull data into a query in Power BI Desktop. Now you can also, if you have a query that's pulling data from anywhere, you can add an R script as a single applied step into the query to do any type of arbitrary transforms. And then the big ticket item that you can do is you can create something which is called an R visual. So we want to see how all those things work inside there. Well, let's start with R code as a data source. Now, what I would recommend is you still begin with RStudio. So back in RStudio here, let's go ahead, remove this stuff inside, and now that we've done that, I've got this one particular script that I've written, And the idea is if we have this script, and notice what this is going to do. It's going to read that CSV file from GitHub. It's going to put some pretty names for the columns. It's then going to do some ordering inside here. So let's go ahead and run this particular script right here. And what you see right here is that I gave the first data set some pretty names. And once we've created that data set and we've given them pretty names, next thing that we're going to do is maybe sort the data. So here's an example of customers, order. Let's sort by age descending. Well, now let's create 3 new objects. So we're going to create subsets of the data for each particular state that I care about, which happens to be Florida, Texas, and California. And so now we have these individual objects right here. Now, the reason I'm showing you this is by the time you import these things into Power BI Desktop, it's going to give you the ability to use any one of these objects. So the very last line of code is going to remove the main data set. Okay, now let's take all this code. Let's now go ahead and start up Power BI Desktop right here. And so let's go ahead and see how we can use this R script to pull data into my Power BI Desktop project. So we're going to go to Get Data. We're going to go to More. And now that we've done that, we're going to go to Other, and there is our script. We'll go ahead, choose that, and here's the box. No IntelliSense, no friendliness here, which is why I strongly encourage you to write the code and test it inside of RStudio before you copy and paste it inside here. But now let's go ahead and choose OK. And what you're going to see is each object that I left, which is a data set, is going to be recognized, and now you can use one of these or all 3 of these to add things inside. Now I can go ahead, I can choose Edit inside here. I can see now all this data that's coming inside. Here's the Florida, here's the California customers. If I want, I can go through here and rename them and give them, friendlier names inside of the object model I'm building in my Power BI Desktop project. Let's go ahead, choose Close and Apply. And so now, once I've run the query, the R script is run, and there's my output inside here. And what's neat is every time we go back and we refresh the data, it basically reruns that R script and does the exact same work for me inside. Okay, so that's step number 1 of using R. We basically use an R script as query import. Well, the next step here is, let's say that, as I'm working with queries, I'm going to bring the query editor back up. Let's go to Florida customers. And now let's go ahead and add a new step. Now, I've imported this data with R, and now I'm going to add an R step. But the typical scenario would be that you've imported the data right from SQL Server. You're about to do some work in Power BI Desktop, but you know how to write some R code that's going to do some tricky stuff, like add categorization to each of the customers, inside of your database. So we're going to click on Run as R script. Now, there's 2 things you have to know about. First of all is that they give you a data set named dataset. So when you start working with it, you have to refer to dataset. And then finally, there is an object they're going to expect you to build, which is named output. So the idea is you work with the data set, but at the very end, you have to write the data set to an object, which is named output. Now, let's go back to RStudio. And once again, I have a little pre-built piece of code inside here. So I'm going to go ahead and take this code, and I'm going to come back here, and I'm going to paste it in. So here what you can see is that there is a data set, which is the data, which is my input. And so I'm going to subset that data. And so maybe I'll say, let's only include ages between 65 and 60, and let's also just pick males inside here. What do I want to do? Do I want to sort the data? Let's say that as I was doing my reports, having male and female spelled out on the report made the report look bad. I want to just go back to M and F. So here's something that's going to basically substitute values inside there. And after I've worked on things, I'm just going to take the data set and write it to output. We go ahead, choose OK. And now that we've done that, you can see it adds two different applied steps. The first is to basically run your R script. The next is to take the output and put it inside there. But now what you can see is that it gives you a way to take an R script and basically add it as just a way to provide any arbitrary transforms as your queries are running in Power BI Desktop. Okay, now, last thing we're going to look at is working with visuals. Now, there is another thing that we're going to look at. And so if I go back to the GitHub repository, there is this project which is called NFL Player Stats with R. Okay, now in this case right here, there's no R that's involved with the importing the data. We're just going to use R to create visualizations inside. Now, another thing to note about this is a fairly tricky project, which is grabbing data from the websites of every single NFL team. It's getting the rosters, and basically it's doing a transform to come up with this set of active players in the NFL. Let's go back here, take a look at the data view inside there. So every team has 52 or 53 players. So it's got about 53 players times 32 teams. And this is something I can refresh every day. Okay, now let's go ahead and look at some of the charts we've created inside here. Let's go ahead and start by adding a R visual inside here. You can see that this is an R visual. Let's go ahead and add a new page right here just to show you adding one from scratch. Let's go ahead and add the R visual inside here. And once I've added the R visual, there's a little screen down below. Now, nothing works until you start adding fields. So for every NFL player, we have a age, we have a weight, we have a height, and we have a number that they wear on their jersey. So one of the things that happens a lot in statistics is you're looking for correlations between data. Now, when you start creating these R visuals, once again, they give you a data frame, which is named dataset. So let's say that I came down here and I say plot dataset. And now that I've done that, this little button right here is actually going to run this particular script and now start creating things for me inside there. Okay, now what gets to be really neat about this is that there are a couple different buttons right here. And so this one particular button that we have right here, actually, let me go back here and cover a couple more slides. First thing I showed you how to do was to deal with R code as query input. We saw that. Next thing I showed you how to do is to add an applied step to a particular query using R code. And so now we're looking at R visuals. And so what we see is that when you add an R visual, Power BI Desktop gives you a little R coding pane down below, and that's where we can write our code. Now, there's some neat new features in September. What you'll notice is that there are these four different buttons that are up in the top right of the R script editor. And so the first one is run the script. What's also nice about running the script here, let's go back here and let's say, I had a typo and I go ahead and run this right here and it fails, and I'm going to click on see details. So could not find the function blot. Okay, fine. So while it's not a great debugger, it kind of gives you a first step into figuring out what the problem was. Now you have a couple other buttons. The next button is the go to data load settings. So here, if I go ahead and click on that, it brings me to the data load settings, and the idea is quite often when I run R scripts, I'm bringing tons of data down, or I might want to clear the cache, so because of the potential to bring down such large amounts of data, they give you just a quick way to get to the data load settings inside here. You have the up and down, which is basically just open or close the code window, and then finally, this button is what's new in September. This is the button that says, take me out of this backward coding environment and take me somewhere good. Let's go ahead and click on this right here. And what you'll see is it takes me, right into Visuals RStudio, and allows me to start doing the work inside there. So what you'll find is when you start inside here and then you branch out, you can get your work done. Okay. Now, note that unlike visuals that you've created with some of the built-in visuals in Power BI, you can't select a bar in a bar chart and have that affect anything. So the R visual itself is not interactive. That being said, I can add, here's just a regular slicer that you can add inside there. So you can add other elements to the page. And so as I add these other elements to the page, what you can see is you can constantly filter the data, and the R visual will basically refresh itself by rerunning your R code on different sets of data inside there. Okay, a couple other interesting things here. Well, here we can see the weight of players in a distribution. You can see that in the NFL, the majority of players are right about 200 pounds. However, there's a bunch in the 300 plus, but there's this big lull in players, that are between 260 and 300 pounds inside there. Okay, and once again, if we want to drill down, on different types of players and things like that, you're able to do that and rerun the R code. Okay, here's a scatter plot. What I was trying to do is promote this theory that in the NFL, as the player's number goes up, the weight is probably going to go up as well. So what you can see is that if I plot all the players in the NFL and we have the number by the weight, my theory doesn't work because there's all these little skinny guys in the 80s that are receivers. Okay, but now if we look at just the defensive players and we rerun that, we see that it's trending up inside here. So as long as I remove all the offensive players, or at least those darn wide receivers, I'm going to be able to prove my theory a little bit more. Here's some fancier charts inside here just to kind of show what you can do. So let's say that I have this average experience by division. I come down here, I now branch out over inside here. And so now that we've done that, let's clear all the other stuff. And so what's really neat is when you branch out, it's going to automatically create this local file right here, which is a CSV file. And so what you're able to do now is, let's go ahead and, work inside here. And, what we should be able to see is that it's going to generate the plot inside there. Let me go ahead and see if I can get that one more time. So now, what we can see is that it's a lot easier for me to work in this environment than it is in that other environment, especially when I'm working with things like the bar plot, and I want to get IntelliSense to be able to, figure out what all the different arguments are that I can pass to something like the bar plot function to create a bar plot inside there. Okay, let's go ahead, and now that we've seen that, let me go ahead and move back now to the slide deck. So what we saw there was that it gets to be pretty convenient and very powerful for you to start learning about the different ways to create charts in R, and then to be able to take that skill and be able to apply it as you're creating reports inside of Power BI Desktop. Okay, now when this thing first came out, it worked in Power BI Desktop, but it didn't work in the Power BI service. However, let's go ahead and publish this. I'll go ahead and publish this work, and over the last couple months, they've made the changes they need so that you'll be able to take your projects that have R visuals, and you'll be able to publish them. And we'll give this just a couple more seconds to complete here. And as this completes, I should now be able to go in and take a look at that. Seems to be taking longer and longer here. Let's go in and see if I can just see app.powerbi.com. And if now we go inside there, and let's say that I now navigate down to that report inside here, here is, what I've created inside of Power BI Desktop as it can be accessed by me and other people I work with, just, inside of the Power BI service through the browser. And once again, all the interactivity that you built inside there, is still going to work as you go through the browser inside. Okay, so now that we've seen that, couple things to note. Limitations. Only data frames are supported in Power BI Desktop. So Power BI Desktop is not going to recognize any other type of data structure inside there. Also, you'll find that some type of complex column and vectors types are not going to be supported, so they can't be imported. Inside of R, you have this idea that a value could be not available as opposed to null. Power BI Desktop doesn't support that, so it just converts all NA values to null upon import. If you have any scripts in R where you're interacting with the user, prompting the user for input, those are going to fail. Don't use those. The R visual, as of August at least, was limited to 150,000 rows. The R visual has a timeout, which is 5 minutes. And as I showed you, the R visual is not in itself interactive, so there's no highlighting support. However, you can add other slicers or other types of filters to the page, which will basically allow you to slice and dice data with an R visual. Okay, lastly, when you're creating charts, don't ever try to use anything other than the standard default output device. So you just use that, and that's what automatically writes there. Okay, if you haven't been looking at the Power BI team blog, I would strongly recommend that you read this, especially the last week of every month when they push out their updates. So in the September update that just came out, they had a whole bunch of new great stuff. One more time, let me plug the Power BI Bootcamp that we're running in Tampa, November 29th, just after Thanksgiving, and January 23rd. It's a 4-day course. You can either come to Tampa or you can attend remotely, and we set up a lab environment that I can help you with your labs. So criticalpathtraining.com for more information. There's a set of material that we're going to cover, a lot of drill down into Power BI Desktop inside of the course. And that takes us to the end. So at this point, I'm going to see if anyone has questions and wants to go into the Q&A panel. We'll be able to support those particular questions inside there. Other than that, I hope everyone enjoyed the webinar today and got something out of it with this introduction to R. And other than that, we'd love to see some of you come and take some of our training, and in particular Power BI Bootcamp from Critical Path Training.